before we start drawing the system, let me show you the element of the program that is called global data. We can access global data from data menu using command global. And now, on the left-hand side, we can see the list of the categories. As you see, there are quite a few categories within global data, and first category, it's called again global data. So as it looks that we've got global data inside the global data, so it's the most global data, or in other words, pure global data that refers to the whole design. And later on, we've got mostly the default data for the specific elements of the system. First, we may enter the name of the project, address of the building, city, and the name of designer. These first 5 fields have gone light green background. That means that these fields are not obligatory. We may enter this data, but we may also leave them empty. Because, for example, if the program doesn't know the name of the designer, of course, it will be still possible to carry out the calculations of the system. However, in the real designs, rather than in training ones, in the real designs, it's rather recommended to enter this data, because then we've got the possibility to have this data also on the printouts, and that makes the printouts more complete. Then we have to enter the climatic information, which are the external design temperature and the mean external temperature. And then we can decide on the scope of calculations. We've got some variants. For example, first, now we've got the design of the new system, and in this system, program selects the radiators sizes and also diameters of the pipes. In some cases, we can switch these options off. For example, now I have switched the selection of radiators. That may be useful when we adjust the existing system to the new heat load, for example, after isolation of the building, additional isolation. And it may happen, it happens quite often, that in that case, even that we adjust the system, we change it a bit, but very often we can leave the old radiators, we don't want to change them. So we can switch this option off. We will have to enter the size of the radiators as they exist in the buildings, and the program won't select them. A very similar situation is in case of second option. When we design a new system, we wish the program to select the diameters of pipes. However, in case of adjusting the existing system, if we don't plan to change the pipes, we also won't wish the program to select the diameters. We wish to keep the old diameters, so we'll have to enter them into the program. As you see, the third option, it's not possible to switch it off. It's the selection of balancing elements or balancing the systems using the possibilities. For example, like selecting the presets on the valves. This is the obligatory option. Let's call it an obligatory program, and the program always carries out this element of calculations. Then we can check the correction of water flex through radiators. We rather have this option checked out in case of designing the new system, because in case of new systems, the water flex depends mostly from the design temperature drop. However, when we adjust the existing system without changing the radiators, it may occur that the radiators may be too big or too small, and changing the water flex may help us to adjust the power of the radiator to the heat load. Of course, changing the flex results in other output of the radiator, and also in this case the temperature drop is different for every radiator. So this option is usually used in case of the existing systems and adjusting of the power, and only sometimes in some cases it's used in case of the new system. Next option is to correct the diameters of pipes under design. This gives the program possibility of using the reduction of diameter as one of the possibilities of the balancing of the system. And then we can also switch the complete report of the fittings necessary to construct the system. This report is available in case of some pipe systems if there is appropriate data in the catalog data of the program. And the last option gives the possibility of the detailed analysis of the flow distribution in the system. Because if the program balances the system, very often it is used by selecting the appropriate presets of the valve. But depending on the valve construction, we have the more or less presets. Sometimes it's just 5, 6, sometimes it's 10 or 20. And especially when the specific valve doesn't have a lot of presets, it may result that the balancing is not done very precisely, and the program can analyze the real flow distribution using the selected presets, and it gives us appropriate messages when some problems arise. And the thing is that this option, this analysis, may take in some cases quite a lot of time, especially using the old computers and having very big designs. So if that happens, it's recommended to switch this option off, at least for the preliminary calculations, because it happens that during the design we start the calculation many times to analyze some parts, some elements of the system. And when our design is almost ready, we can switch this option on to have some more precise diagnosis of the system. So in this example, let's select the first 3 options and unselect all the others. This is quite a typical set of options for the design of the new system. And now the second category of data is data about stories. As you see, in this form, all the fields have got already some values, and these values are presented with the green font. Green font means that these values are some kind of automatic values, in this case suggested by the program, rather than values entered manually by the user. This group of data is related to the main philosophy of the program, which is creation of the complete 3-dimensional model of the system. However, to make it easier and faster, the users don't create the 3D model completely manually, but they draw only the 2-dimensional plan views of the system. And the 3rd dimension, the vertical dimension, is created automatically by the system using the values of the levels of the specific elements of the system. And it happens that very often these values are very standard values. That very often we've got the radiators, majority at least of radiators, on the same level. And the same happens with other elements of the system, for example, pipes. Let me show you that using the example of pipes. As you see, by default, for the supply pipe, this red one, the level is minus 0.05 meters, which means minus 5 centimeters in the reference to the surface of the floor. That means that pipes are laid 5 centimeters under the surface of the floor. And this is the standard data for the whole system, for the whole design. Later on, we can define other data for the specific stories, if the stories are a little bit untypical, let's say. And at the end, when we've got the specific pipe that is on the other level, we can enter this value for this pipe. I will come back to this topic later on when I'll talk about drawing the pipe network. So, as you see, we can really save a lot of time if we find out properly what is the standard value and what is the exception. Because if we use it the other way and we treat exception as a standard value and vice versa, of course we won't save that much time. The next tab is for the heat sources. We've got 3 levels of entering data about heat sources. In the upper part of the window, we've got the global default data for all possible heat sources in our system. Underneath, we've got the table with the classes, giving us possibility of declaring different data for different classes of heat sources. And later on, when we put the heat source in our design, we can define the data for the specific heat source. This idea results from the fact that in the software from the version 4.0, it's possible to have more systems in one design and more heat sources. If you have, what's very often the case, only one heat source in our design, so it doesn't really matter, you spend more or less the same time if you put this data here in the global data or in the table beneath, or for the specific heat source when you put it in the drawing. So first we have to decide what's the agent. By default is water, but it may be also glycol. For glycol we have to also specify the concentration. Then very important data is the temperature. First the supply temperature and temperature drop. By default is supply temperature is 80 degrees Celsius and temperature drop 20 kelvins, which means that the return temperature is 60 degrees Celsius. But if, for example, we wish to design a low temperature system, we may change it and enter, for example, supply temperature of 45 degrees Celsius and temperature drop 10. So we've got the system 45 by 35. Then a very important fact is the hydraulic resistance. We have to enter the pressure drop on the heat source, and we've got 3 possibilities. We can enter it as pressure drop in pascals, if we know this value, or we can also enter zeta coefficient or kV value. And then the program will estimate the exact pressure drop in pascals after calculating the flow through the heat source. Then we enter the default capacity of heat source, for example 15 liters, and then the available pressure. As you see, by default it's not a specific value, it's just the command calculate. It means that the program will calculate the necessary pressure. However, sometimes it may happen that, for example, if you design not the whole system but just a part of it, for example a system in one apartment, then you may have already the disposal pressure for this part of the system, for example 20 kilopascals. However, in most cases you won't enter this value, you would just leave calculate. Then the next field would decide whether the program should warn the designer if the hydraulic resistance of the system is very high, and here you can enter the value when this warning should start. By default it's 40 kilopascals. And then you can also decide whether the program should treat the heat source as a designed one, a new one, or existing. That influences the report of the materials necessary to create the system. And this is the global set of data for all kinds of systems, but if it's necessary, if it's useful for you, you can also define the default parameters for the specific class. For example, for electric water heater, we can have a different values. The next tab is quite important because it's about pipes. And this is one of the really few things that it's absolutely obligatory. This is to select the pipes that you wish to use in your system and the insulation. The pipes you select in this table. If you enter in this field, then you can pull it down like that, and the catalog of pipes opens. Then you select a pipe that you wish. This would be just an example. I would just choose the first one, and when I press select, then it's entered in the table. In the first row, when we've got the type A, it means that we have associated this specific pipe with the symbol A, and later on in our design we would just use the symbol A, and wherever we use A, the program will know which pipe we wish to apply. We can select more than one pipe. For example, this one as B, and in the table beneath you've got the available diameters for the specific pipe, and then you can decide on the data. As you see, most data are already filled by default, but you can check it. Just to show you an example, if you don't wish to use the smallest diameter, the diameter 10, you can exclude it, and the program won't select diameter 10, will start from diameter 14. And here's a good example of showing you once again the idea of inheriting data. If you have a look at the maximum linear pressure drop, for example, now it's 150 pascals per meter, and this is the global default data for all possible pipes, all possible diameters. If you have a look at the table beneath, then you would notice that for both pipes you have the same value inherited from the global value. But let's say that we would like for the pipe B a different value, for example 120, and then this value will be the default value for this pipe, for pipe B, for all the diameters. However, we can come to the table beneath, and for each diameter, if necessary, we can create different values. So as you see, this is quite flexible system of inheriting data, and sometimes it may be useful for specific situations. However, it's not obligatory. In most cases, you would just have one value for the whole system. The second information that you have to enter, you have to choose the default installation, for example, PE foam. So these two information are really necessary, really obligatory: the types of pipe and the type of installation. The next tab is accessories. And in the upper part of window, you've got the parameters for selecting the different types of accessories. As you see, we have some default data. If you wish, if you know that it's necessary, it's correct, you may change them. If not, you can just leave them as they are. However, what's much more useful, much more commonly used, it's the table beneath, because here you can define the default data for the specific class of the accessories. It is especially useful to enter the symbol or to choose the symbol, because very often you've got a lot of accessories of the same class, of the same type in the system. So if you decide here, for example, what kind of ball valve to use, so you won't have to enter this data again and again many times. You would just enter it once in this table in global data, and then you would just enter the accessory into the drawing, and the program would already know which type to assume. Of course, it's always possible to create an exception and say that this ball valve is of another type. This technique, on one hand, saves a lot of time, but it's got also another advantage. If you wish to change the type of the specific class of accessory, you can do it very fast, because you just change it here in the global data, and whenever it wasn't created an exception, it would be corrected automatically. In the similar way, you may enter the data in the following tabs. As you see, there are really a lot of fields here with possibility of entering lots of information. However, in majority of cases, you just use a small percentage of them. Only these ones that are important, that are useful for your specific case. What's really obligatory is to enter global data and to select the appropriate scope of calculations reasonable for your design. And it's also obligatory to enter Pipes tab and to select the types of pipes and the insulation material.